Let's go over the SN1 reaction mechanism. And for the SN1, what works the best is a tertiary haloalkane. So let's have this one as an example. And in the first step of the reaction mechanism, what happens is that you will be forming a carbocation. And your halogen is your leaving group. It had 3 lone pairs, but now after this bond breaks, now you will have 4 lone pairs for the halogen, meaning now you will have a full negative charge on the halogen, and you will end up with just 3 bonds for this carbon, meaning you will have a positive charge. So this is your carbocation. This is the first step of the mechanism. This is also the rate determining step. As you can note here, that only this compound, the haloalkane, is participating in the rate determining step. So later on, when we are talking about the kinetics will only depend on the concentration of the haloalkane, because at this point, the nucleophile is not participating in the rate determining step. The second step of the SN1 reaction mechanism is that now you will have a carbocation, and now this is the point when you introduce your nucleophile. And for SN1 reactions, you want a poor nucleophile. So let's just use methanol, CH3OH. This is your methanol. The carbocation, this is your electrophile. And keep in mind that when you are reacting a nucleophile, in this case the methanol is your nucleophile, with an electrophile, you end up forming a new covalent bond. The arrow goes from the source of electrons to their destination, to this carbon right here. And what you will have is now a new bond between this carbon and this oxygen. And what is attached to this oxygen is this hydrogen and CH3. You use 1 lone pair to form this bond. Now you just have 1 left. And because of that, you have 3 single bonds and 1 lone pair. You will have a positive charge on the oxygen. So that is step number 2. Let's take a look at step number 3. You will have the oxonium ion. This is known as the oxonium ion. So let's just draw it again here. And now you have oxygen with a positive charge. Oxygen does not like to have a positive charge on it because it's an electronegative atom. So whenever you have an oxygen with a positive charge, you want to find a way to remove that charge. So you have another molecule of methanol. Oxygen with 2 lone pairs. And now what you will use is 1 lone pair, and this will take this proton, and then the electrons that you have between the hydrogen and the oxygen, they're gonna go back to this oxygen. Now you will have the oxygen with a CH3. You no longer have the oxygen, and your protonated alcohol. This oxygen will have now 2 hydrogens, So now you end up forming an ether. This is your reaction product from the SN1 mechanism.